Hey guys, this is the video for 10.5. We're going to be talking about completing the square. So what completing the square deals with is when we come across a binomial or a trinomial that we can't really factor. We can't come up with terms of c, factors of c that add together to be b. So this is the trick we can use to make it factorable. Okay? So completing the square, all we're going to do is we're going to take whatever our b term is, divide it by 2, square it, and we're going to add that to a binomial that has this form, x squared plus bx. Okay, so we're essentially adding c. And we're adding a very special c so that we can factor it, okay, to create a perfect square trinomial. That's all this part means, okay? All this means, perfect square trinomial, is that we can factor it. So in this example, I want to come up with an n that would make this a perfect square trinomial, meaning it could be factored, okay? So I'm going to use this trick of completing the square. I'm going to do b over 2 squared. So b in this case is negative 12. So I'm just going to do negative 12 over 2 squared. And we could simplify that. Negative 12 divided by 2 is negative 6. So I have negative 6 squared, which equals 36. So if I rewrote this trinomial with 36 in for n, minus 12x plus 36, now this is something that I could factor. Factors of 36 that add to be negative 12, well that happens to be this term that I just added, that negative 6. So this could actually factor to be x minus 6 times x minus 6, which I could rewrite as quantity x minus 6 squared. So that's the cool thing about completing the square. It's always going to be factored into x plus whatever this term was squared. Okay, so let's do an example where we're actually solving a quadratic equation. Okay, so if I have on my sheet here. Okay, so if I'm solving this equation, x squared plus 9x equals 136. Okay, so if I want to solve this, I could subtract 136 from both sides, but I still can't factor that very easily. Come up with the factors of negative 136 that add to be 9. So I'm going to use my completing the square method. This is an x squared plus bx. Okay, so I could add that b over 2 squared to make that factorable. But this is an equation, so I have to do that to both sides. Okay, to keep my equation balanced. Now b over 2 squared in this case would be 9 over 2 squared. Okay, so when I do that, x squared plus 9x plus 9 over 2 squared. And then this 9 squared would be 81, and 2 squared would be 4. Now, this is what we just learned from that example. This is always going to factor to be x plus whatever term I just added squared. Okay? Equals 136, I want to convert that to fourths so that I can add these. This is 544 fourths plus 81 fourths. And once I add these two, this simplifies to be 625 fourths. Now my whole goal here is to come up with a solution, solve for x. So when I do that, I need to get x by itself. First thing I need to do is take the square root. So after I take the square root of both sides, I get rid of my squared over here, so I'm just left with x plus 9/2 equals square root of 625 is 25, and square root of 4 is 2. Now, I inserted that square root, so that's where we talked about I have to have both a positive and a negative, okay? So this means I'm essentially solving two equations now. Okay, I need to solve the equation x plus 9/2 equals 25. And x plus 9/2 equals negative 25. Those are going to be my two solutions. And then I just proceed in solving. Sorry, this should be 25 over 2. Okay, so we subtract 9/2 from both sides. So I'm essentially solving two equations simultaneously here. Okay, and 25 minus 9 is going to give me 16, so I have 16 over 2, which is 8. So x equals 8, or negative 9 minus 25, that's going to give me a negative 34. So negative 34 over 2 is going to be a negative 17. So those are my two solutions. And if we substituted those back into my original quadratic, we would see that those would work. Okay? So I want you guys to complete that notes page, go through an example on your own, and then you'll be working on problems just like this in class tomorrow.